All right. So change of position from the beginning of the race to the end of the race? 0. It's like a big middle finger to the environment. Okay. We're going to drive 500 miles, but not go anywhere. So your displacement is 0. So what is the average velocity of the winner every year? Every year they tie the record. The record is 0. Okay. So the record average speed, 238, but the record average velocity equals 0 miles per hour every year. Okay. Provided they finish the lap, their change of position is 0. So their average velocity is 0. All right. Average speed, though, total distance, 500 miles divided by 3 some odd hours. That gets you that. Here's another way of finding the average velocity is just to connect the beginning and end point. So here's where it starts. Here's where it ends. And if I find, it's a terrible line, slope of line between, what's text speak for between? We'll hope that's it. Between endpoints equals average velocity. Okay, so if I do that, that'll give me the average velocity from 0 to 16 seconds. Looks like that's going to be 8 meters minus 0. This is how we say don't do the best fit line this way, but we're going to do it this way to find the average velocity for the thing. 8 meters minus 0 divided by 16 seconds minus 0 seconds. That's going to be 8 meters divided by 16 seconds. Who's got a calculator? Wait, I got this. There we go. 0.5 meters per second.
What does that say up by the
Yeah, that's kind of a lot. Slope of the line between the endpoints is a way to get the average velocity. So I just put a dot at the beginning. Here's where it started. Here's where it ended. And the slope of that line gives you the average velocity. Because when I do that, that's going to allow me to calculate the change in position and divide it by the change in time. All right, distinguish that from the distance traveled divided by the time, okay? Run that by your neighbor and see what kind of a value you get for the average speed. And then, oh man, come on, dude. Boop. And then once you've got a value for the average speed, go ahead and put that into the pear deck. Ooh, and while you're doing that, let me try to hand back your quiz from last week that I've been sitting on. It's on the average speed from 0 to 16.
Why not? Okay, but just.
I don't know. Like, it'd be fine, but I just think it's like.
Just like a little weird.
I feel like I don't know if like.
Oh,
Like, I think it would have to be.
okay, I got you. So, can you go to
I think it's like toss-up.
Oh, there's somebody ones that are a lot of them are like that.
System,
But they all just, I don't know if you really
Yeah, I don't know either.
what's going on there. Everybody's just on drugs and falling at this.
So,
K08.
thank you.
Probably welcome. Right. Ram. Jimmy. Perfect time.
Yeah, no. But also, like, there's not really weird. You're gonna do what?
Yes.
You have to make sure it's the right person.
Yeah. If they're cute too.
Because some people might be like, who are you? But I think most people would be like, okay, yeah,
Yeah.
let's go.
Oh, and I'm struggling with this data.
Just heard her.
Garbage.
Thank you. Why do I keep getting twos in this?
Why is my
You should.
Joe.
He would. I feel like you would like it.
Oh boy.
Actually, I don't really know.
Medicare.
I feel like you would get panicked. You would start panicking because it automatically like makes my heart rate go and stuff anyway. So you're like always like, you know. But everything's exciting. Like when it's just like anything that's happening, it's like, oh my god, this is so cool. Like everything. And like if I talk, like if I'm talking about something, I'm so much more like excited about it. Like it's so weird. Like I'll catch myself and like, oh my god, like, and I'm like, I'm literally talking about nothing. Like be talking about the most simple thing, and I'm just like so talking so excited. And so is everyone else. It's a good conversation.
Oh, what I do?
But it only lasts like 15 minutes. Which is not bad. Yeah, I didn't even really know that until like last summer, but like it's like 15 minutes of it. It's maybe like just it's just like
5,000.
it's hard. So okay, so I would we can just FaceTime.
No, I can't go there alone.
All right. Hopefully you're throwing a number in here for me.
He was just funny.
All right. Hey, I've only heard from 7 folks on the average speed thing, so get in there if you would, please. What is the skater's average speed from 0 to 16 seconds? We're talking the distance traveled, so the Fitbit reading, divided by the time. Ooh, yikes. That's not good for the battery.
So it's just like adding like
It is 12 divided by 16. 12 meters and 16 seconds. Yeah.
if that would
Because one of this yesterday. From 0 to 16. I don't know.
What shape?
Why did we put 12 on the top?
because like 4 plus 6 plus 2.
Oh, we added up all the total distance. So it's, this is 4, and then nothing else, we stay at 4. And this is
Did you get that
6
stuff?
meters, because 4. So we added all the meters up total, and it equals 12. Is that how you do it? No, the speed isn't the number. I mean, the seconds is not. It says average speed is the distance traveled along the platform. So we did the distance divided by the time, which is 16 seconds. I don't know. I got 0.7. Riley, what did you get for that? 0.75? Yes. Yeah. Thank you.
I really
Why? It won't let me. Yeah, it won't let me. I just typed in a number. Okay, so it's already about
Yeah.
so
Part of the issue.
What did you see from this one?
No. I woke up at 5:15 to feed my dogs and went back to bed till 7:15 to walk my dogs because he licked my face. Woke me up. Well, my parents have been out of town all week, so I've had to walk. What? Yeah. Did you see me this morning? Yeah. What?
Tell me if this is a bad idea, okay?
What?
This is a bad idea.
Yes.
Why?
Yes.
Why?
Because if you have any hope of wanting to get there, that is ruining it in one single.
I know, but if I don't, what if I...
Well, give yourself more time to figure out if you really don't. I'm serious. No. You think it's fun until it happens and you're going to call me like, why the fuck did I do that? So no. I don't even care. You're not doing it. You're not allowed to. Go to Iowa. Shut the fuck up. Go to Iowa.
I literally...
No.
This
Stop,
month,
no.
when I was there this month...
Stop talking. It's not an option. I will let you do anything. Literally, I don't care you do. Just don't do that. Because you're just going to regret it and hate yourself for it. So there's literally no point in doing it.
Why?
Because it's... No. Stop. I'm going to like all the stupid pictures on your phone if you don't stop looking at his Instagram.
Let's find Aladdin. He's from Florida.
Oh my god. Or Florida on a college visit. Like, I don't care. Just don't do that. No. No.
You can find something for me.
At Kirkland.
Okay, so when you go if you go look at your Power School, it's not quiz 1, quiz 2, or anything like that. It's the essential understandings 1.1, 1.2, 1.3, 1.4. So if you got 3s this week, I just go in and I change. Like if you had a 2 last week and now it's a 3, it gets changed. Okay. Or if you had a 3 and now it's a 2, that gets changed as well. That doesn't happen very often. So they're not entered as discrete quizzes. They are the separate essential understandings. Okay. So I've got you answering over here on average speed. Did we get a few more folks? Hopefully. Where are we at? 16. I guess we'll call that close enough for government work. A lot of folks are getting something close to 1. There's some that are greater than 1, and there are some that are less than 1 for the average speed. So let's take a look at that because we've got some variation here. I guess we can look at the individual answers. 0.5, 1.875, 0.75, 0.5, 1.875, 1.75. Okay, so these are all a little bit different. So when we're talking about total distance in this context, I want to take this graph and break it down into segments and look at how far did we travel in each segment. So let's see if I can get this thing to play ball here. There we go. All right. So if you look at this first part of the graph, give me yellow, buddy. There we go. This first part of the graph, we go 4 meters. Then we go 0 meters. Then we go from 4 to 2, so that's 2 meters. I don't say -2 because it doesn't care about direction. It's just the distance. Then in this section, we go 0 meters. And in this last chunk, we go from 2 out to 8, we go 6 meters. So total distance, I want to add the Fitbit distance of each one of those chunks, is going to be 4 meters plus 0 plus 2 meters plus 0 plus 6 meters. Who's got a calculator? Wait, I got it. There we go. 12 meters. That's the total distance. The total time is 16 seconds. So for the average speed, I'm going to go.
Your screen's frozen.
Oh, thank you. Not helpful. It's working for me. 12 meters divided by 16 seconds. You're a good friend. That was Ms. Eustace the other week. Like, let me know I had a little boogie hanging on my nose. You're that kind of a friend. I like those types of people. Not going to just let me sit there looking stupid like Kato 8 was going
I
to.
didn't even know.
All right.
She told me.
Fair enough. Yeah, but she didn't tell me.
Yeah.
Yes, that's even worse on her. Like, he doesn't even know it's frozen. He's so silly. All right, 12 meters divided by 16 seconds. That's 3/4, but you know that I don't like fractions, so you would write 0.75 meters per second there for the average speed. Okay?
Oh, that's a high five.
So be mindful of that, friends. Okay? when you're talking about average speed, when you're talking about average distance. Distance just cares about, average velocity just cares about where you ended up and where you started. But average speed cares about the whole thing, the distance, okay? F and G, what situation is average speed a better measure of motion than average velocity? I would say an example like the Indy 500, because the average velocity is 0. That doesn't really tell you much about what happened, okay? But the average speed of 238 miles per hour tells you, like, I want to find other things to do with my life. That sounds kind of dangerous, okay? I don't know that this is a better measure, but one example that I can think of average velocity, if you ever go driving through the great state of Indiana, when you pull in on the left side of Indiana by Chicago, it's kind of like pulling into a parking ramp. Like you hit the button and it gives you a little ticket with a little magnetic strip and whatnot. And then whatever off ramp you take, you hand them that paper, and then they know, like, oh, okay, you traveled 50 miles through the great state of Indiana, your toll is $1, okay? Or you go a little farther over, you traveled 150 miles through the great state of Indiana, your toll is $1.50, okay? But it also timestamps when you came into Indiana on the left side. So it knows not only did you just travel 150 miles, but you did it a little bit too quickly, and so you get a speeding ticket as well. Okay, so it takes your change of position and divides by your time there. So your speeding ticket is based on your average velocity across the great state of Indiana. Yes. So how do you beat that system? You stop for gas. When you pull off though, like you get the exit ramp, right? So you just kind of like just hit the shoulder, just change your tires just for kicks or something. Find something to do. Cause man, I don't want to drive 55. You know how maddening that is? Like I'll drive fast and then I'll pull over and we'll go look at some deer on the side of the road or something. Okay. That's another cool thing about the great state of Indiana. They have like an electronic eye set up along the perimeter of the roadway. So if little woodland creatures scurry, big woodland creatures scurry through it, like a deer, it sets off flashing lights like half a mile either side of that, so you know there's and then you can slow down and not hit the deer, hopefully. So you don't have all that like grotesque, macabre, like smashed deer art like we have all over Iowa when you're driving. Like, I think that's the butt, okay? Like you don't have that in Indiana. You don't have to guess at the parts because there are no dead deer on the side of the road. It's just gross. Pink mist. All right, cool. Let's take a look. Let's do a little self-check on average velocity and average speed. Hey, friends, this is going to show up on the quiz tomorrow. This is one of the essential understandings for for the constant velocity particle model. This is essential. You know what? We actually got a couple we're unpacking here. We've done position versus time graphs. We've done motion maps. That's 2.1. You know how to find the velocity from the position versus time graph because velocity is what? Velocity is begins with ends with slope on a position versus time graph. There you go, you got it. All right, that's what velocity is. Slope on a position versus time graph. Average velocity versus average speed. We just talked about that. I talked in teaching, but 2.3. So that's why I want you to practice that here real quick. And then hey, we haven't done that one. We don't know that yet. Ooh, down here, 2.8. I can distinguish the difference. There's it talks, Cardi. I can distinguish the difference between distance and displacement. That's too many E's in one sentence. And calculate both. Well, the big thing is distinguishing them. So if I ask you total distance or total displacement. All right, so I'm going to shut up and throw this at you, okay? Here are 6 graphs, okay? 6 graphs of position versus time. So this object has that for position time graph, okay? You are to rank them based on the greatest average velocity from the beginning to the end of the motion, okay? So I'm going to throw this up here and then change up the pear deck here. Where'd that go? Boop, boop. When you are doing a ranking, I think this is the first time we've done a ranking this year. These are labeled A, B, C, D, E, F. So your ranking might look like F greater than A equal to C greater than D. It's not frozen, is it? Oh, okay, cool. So you got to figure out which of these graphs shows the greatest average velocity.
Did we do something like this?
Yeah, boss.
What are we ranking on?
Hopefully you take more fast than you remember that.
Velocity.
Well. Here, it says it right here.
That's like the total change.
The displacement, final position minus initial position divided by time.
So this would be 0.
Final position minus
This would be
initial
0.
position. You see
Oh
it?
my goodness. Look
Divided
at
by
everybody's new picture.
time. Oh gosh.
So handsome. Your hair looks so good that day. There you go.
I had my picture. And Riley made me that. Where's it on?
What up?
Is this George? No.
No, a ranking tab. But I mean, I might give you a graph next with the average speed, your average velocity.
Yeah, I don't think I think my mom gave me shoes and I never did them into that. And I never wanted that. Yeah. Okay, final position. Which one do you go by the position? 25 minus 25 over 10. That's how you do it.
0.
Am I talking about 0 over 10 is 0.
All right, I got 4 folks in so far. Trying to catch up.
How would
Ranking on average velocity.
What?
Average velocity.
It's 0.
I'm sorry, my brain doesn't do that. I have to write it down.
It's a freaking straight line.
My brain doesn't do that. 0 minus
This is 10. This is
over
1.
over 10. Can there be negatives?
Yeah. No, that's not negative.
Why?
It's not going down.
But 0 minus 10 is minus 10.
Oh, wow.
You feel me? 0. Oh, fuck, I forgot it's supposed to be 10 minus 10. God damn, why am I like this?
So is it 0 or is it 10?
It's 1.
That's what I thought.
Then tell me next time.
I did, and you weren't listening to me.
10
This
minus
one's
7
7.
over 10
That
equals
lightning that
10
sounded
Now
really
this
close.
one is
Was
No,
really
how did
close.
you? I got
Anybody
7
live on
tenths.
Galway Drive?
what drive?
I want to check on your dog.
What did you say?
You live on Galway?
No.
Okay, you're good. Don't worry about it. That lightning that sounded close was close. It was here to us.
Oh yeah, that was really close. We were driving here, and it was kind of like right there.
I moved a little bit.
Yeah.
Here.
I can't do it. See, what did you get for this one?
There we go.
What did you get for it? What did you get for it?
This one is 5.
You're really pissing me off. I
Done.
got you with the first three, and now they're not making sense. Okay. Can you tell me what you got for D?
It's literally how much they changed it.
I got 7 tenths. Okay, so what did you get for the next one? Why? I have you 50. But
All
what
right, I
did you
got
negative?
13 people in. That's almost half of us. Come on, let's go.
So it's
Average
15
velocity.
over 10.
Rank it.
What's the last one? Oh, wait.
5
So minus 0 over 10.
It's a half.
5. Oh gosh.
Are we writing them for March?
Oh, you just got me.
What?
Okay, so which one's the biggest? Did you say E was the biggest?
All right, so I've got 0.1666667, which is a number but not a ranking. Then we got C greater than D greater than F greater than A, E greater than E.
Wait, why is E not?
That looks pretty universal for the folks that bothered inputting, okay?
They're equal.
So yeah, Mr. Harding, we got this. A and B are equal and E is the least, okay? Almost the universal there. Why is E the least? Because this ranking goes from most positive to most negative. And so if you calculate the average velocity for E, you've got 15 minus 0, or I'm sorry, you got 0 minus 15 divided by 10 minus 0. So negative 15 over 10, you got negative 1.5 meters per second on the average velocity there. Or, all right, next ranking.
I don't know.
How do things change when we rank on average speed? So how do things change when we go on average speed? So let me ask a new question. New question. There we go. Boop. Fitbit distance for average speed.
We're doing speed now.
Same math, but now on something different. Whoa.
Since travel to long. Oh, so we have to add it all up. So is this no distance?
It's 5 over 2.
I don't know. Okay, this is because it's still at 25. Yeah, I think I'm at 6. And then over 20, so 0.
0. 0. What do you think?
This one would be, I forgot what the questions are. Distance traveled along the track divided by 2.
1 7.
What did you say?
It'd be 10 over 10. It'd be 1.
Oh, yeah.
The only one that's different is F, isn't it? 10 plus 5.
Wait, the distance on this one would be 7 over 10, right? So it's 0 on this side.
No, the time.
Distance on this one would be
He's just saying.
what is the distance on it?
Oh, you just put it
Negative 5. This one would be 15 over 10. And what did you say? What was the distance? Like I'm doing distance divided by time. Did you get? No, like for what did you get for the speed? Like what's the speed? How did you get it? How did you get it? Hey, Austin.
I've only got 9 in at the moment, so Cal, can you grip your own shirt?
Not like yeah, not like that's common. What is E like? How do you figure out the distance? Because I'm doing distance. It doesn't change from 15?
Wait, what do you mean?
Wait, like how did you figure out?
It's just 15 to the 0 to 15.
What's up, sir?
Over
Was this the correct?
This is, okay, I did the wrong way.
I think so.
I did the
Yep.
bottom one.
Thank you.
So it's negative 17 over 10? No, it's just 15. So it's
It
the
doesn't
same.
matter if it's positive.
So it's 1.5 for both answers.
Yeah. So they're both equal. The zeros.
That's what I got for all of them. I don't know. I don't understand that one.
This one is 1.
Or like this.
Yeah.
This one's 1. So neither of them really.
This one, because
Right, because
you added up on the speed but not on the velocity. So we just did. Well, if you were staring at me, I'd be uncomfortable. She said, "No, just like stare."
Right on.
She just looks uncomfortable.
All right, so when I look in the thing, here are the three answers I'm seeing right now. So slightly different as to where F ranks relative to E. Some people have F near the back end of the ranking. Some people have F equal to E and out front. Some people have C out front. Okay, so run that by your neighbor. Everybody agrees that A and E are equal and they're the back end, which is good because they don't go anywhere. Their average velocity is 0. It starts at 25, it ends at 25.
I get like,
I don't know, it's weird.
okay, what
Everybody was
goes
like
after
that.
E and F? So the first one. That one. The last one. Uh-huh. No, I mean, it wasn't mine. That's what I did. It took me a while to figure it out. He always goes first.
So if we're talking average speed, how far does this thing walk in C? Like your distance here is going to be 10 meters, okay? For D, your distance here, you're just going from 3 to 7. Your distance is 7 meters. E, and again, this is the difference when we're talking about distance. It doesn't care which direction you walked. It's going to say 15 meters. And F, your distance, again, you went 10 and then you went 5. If that's a Fitbit, it's going to say you walked a total of 15 meters, okay? All these are over 10 seconds. So E and F equal, then C, then D, and then finally B and A. All right.
Is there hang on what website are you on?
So we just have a little bit of time left. I'm going to try to pre-lab where we're going next. We should have time for this after the quiz tomorrow. So I'll get some of this out of the way. There's a video that I'm going to have you watch on Canvas. So let me find that. Just do that between now and then, hopefully. Let's see.
Are you not?
Oh, yeah. Yeah, hey, pass your quizzes on down to the Kiana end of the room.
Is it this one? Watch the video. Look, my $2 printer is already broken.
Ruh-roh.
Kevin?
All right, so hey, wow, Mr. Harding, I didn't put in a Wednesday or a Thursday yet. Here's friends. This is Friday's Canvas page, but I'd like you to check out this video if that's what it takes you to. I think it does. Before class, okay? Hey, so this is going to lead you through how to hook up everything that you're going to need tomorrow. Which would be super great to watch in advance. Let's see. The other thing that it doesn't talk about in the video, but that I'm going to need you to do is on your Chromebook. So good thing you still got your Chromebook out. Is go to the Chrome Web App Store, and you're going to need a program called Graphical Analysis. I don't want to punk everybody on the projector. There we go. Find it. Find it. Find it. There we go. You're going to need a program called Graphical Analysis, okay? It's an app, I should say. Oops, I don't want that up. Okay? The icon looks like that, little wavy lines. Graphical Analysis, okay? And that'll work with the probes that we have here. You can see right now it's setting up to graph two things. It's setting up to graph position, and then down here it says velocity. What is velocity again? Run it by your neighbor. You said by somebody smart, what is velocity? Begins with ends with lope on a position versus time graph. Okay. So if I didn't want to write, if I didn't know this word velocity, I could just write here slope on a position versus time graph. And then what type of graph is this then? This is a slope on a position versus time graph. Okay, that's what this graph becomes. It's a slope on a position versus time graph. This one is just a position versus time graph. That's pretty straightforward. But I just want to worry about the position graph at the moment. So I'm going to switch this to one graph. And that is one graph of position. So I need a swimmer. Do we have one? Who's a swimmer?
Austin does diving.
That's not swimming. Yeah, I've seen what diving practice looks like. It looks like a lot of standing around. So, all right. Swimmers? No swimmers. Okay. Are you also a diver? Okay. Yeah. Anybody athletic? Yeah, what do you do?
I play basketball, softball.
Okay, cool. That counts. Grace's going to come over here.
Next, don't listen here. It's a trick question every time.
Basketball. Oh, man. Never mind. It's going to be good. I wasn't reading the clock right, Grace. Sorry. We'll use it tomorrow. So, yeah, just do that. Friends, two things. Watch the video on Canvas. And make sure you've got graphical analysis on your Chromebook. And then we're good to go. And be ready for a quiz tomorrow. Review your worksheets. The worksheets that we've gone over.
Should I go into like